there is more to it than meets the eye, they say. Hi, my name is Arturo Mayorga, and today I'll talk to you about hyperspectral imaging as a non-destructive technique to assess food quality. The agro-industry faces strict rules to assure food quality and safety of fruits. And we know that quality is not a single well-defined attribute, but it involves several characteristics of the crop, such as smell, taste, shape, or absence of defects such as bruises or scratches. Current conventional methods to assess food quality can be laborious, time-consuming, and therefore it has become a priority to develop new sensors that are efficient, environmentally friendly, and most importantly, non-destructive. Machine vision and spectroscopy are methods that meet these characteristics. Spectroscopy studies the interaction between matter and electromagnetic radiation. We know that light behaves like a wave, but also like massless particles called photons. And photons travel at a certain speed. They carry an amount of energy proportional to the light frequency, as we can see in this diagram. And when photons interact with atoms or molecules of a material, the behavior of light changes. And this behavior depends on the electromagnetic spectrum. Therefore, we can assess the quality of a material based on its light absorption. However, it is difficult to locate this information in space, but we can do that with machine vision. Machine vision gathers the spatial information of the external part of a material. It consists of a camera connected to a computer and software for image analysis. However, since machine vision is operated at wavelengths within the visible range, it has certain limitations. For instance, concavities, stem, or calyx could be misclassified as blemishes in the fruit because this technology shows inefficiency when measuring objects of similar colors. But if you combine the strong and weak points of machine vision and spectroscopy, we get a powerful tool that we call hyperspectral imaging technology. This system consists of a camera which gathers spatial information of the sample that we place in a moving platform, and this spectrograph gets details, fingerprints of the sample by using some physical characteristics such as reflectance or transmittance due to the interaction between the sample and the electromagnetic radiation coming from these illumination units. And all this information is stored in a computer for future analysis. Okay, so now I'm going to present an example of an answering spectra of wavelength versus reflectance. And as we can see in this diagram, we have many peaks and valleys due to the structural complexity of the fruit. And since we have so much information, we require statistical methods to, for example, select the significant wavelengths to predict a certain quality attribute. As we can see in this diagram, this technology has the potential to sort fruit into different maturity stages. And this is because molecular stretching and bending absorb radiation within the infrared region, as we see in this figure. Therefore, we can assess or quantify organic compounds such as sugars or organic acids or pigments in fruits. And yes, the composition of the fruit changes and it depends on its quality. For example, insects are made mostly of proteins and fats. Therefore, a fruit infested with larvae will show a notable response at wavelengths at which we can detect proteins and fats. Also, bruising can be identified even when it isn't yet visible to the naked eye because the composition of a bruised area is different from the composition of the sound area. So to wrap this up, there is a need for efficient, environmentally friendly, non-destructive techniques to assess food quality, and the hyperspectral imaging technology meets these characteristics. It combines the principle of both machine vision and spectroscopy to gather spatial and spectral information of the sample. And depending on the data approach, we can use this technology to predict the components of the fruit, such as sugars or organic acids, or we can use it to segregate and sort fruit into different categories, such as maturity stages or healthy and infected fruits. Thank you very much for your attention.